bardziej zapowiedzieć niż Tomasz przed państwem, strasznie oficjalnie. Tomasz Wróbel, prelekcja Why Security. Wytłumaczy się, dlaczego niebezpiecznik.
Dobra, zaczynamy? Welcome to the talk with the mysterious title, Why Security? Correctly in English, it should be written this way. Why security? But first of all, who am I? My name is Tomasz Wróbel. I'm working for Seco Poland. I'm a software designer and developer, and within that role, I put a lot of focus on security. That's why some of my colleagues call me security-minded developer. Let's begin with why I'm talking about security on Developers Conference. On Conference for Developers, I often hear developers saying, I'm not going to see this talk. This is a security talk. It's for security guys, not developers. I'm glad that not everyone thinks this way, as evidenced by the fact that you are here. I believe that you haven't chosen this talk only because it's on the main stage and it has a mysterious title, but you have some interest in security, which is great. And because of that, you maybe have heard in the past, or you will hear in the future, such a question from your product owner or manager. Why security? Why you want to add another security task into the backlog? Our application is already secure, right? Right? This could be followed by other question with some buzzwords like, and what about the SAST and WAF and DAST that we already have? Is that not enough? And what about the security features our cloud provider offers us? Is that not enough? Such a list from the cloud providers with security service can be pretty long. Here's the list of Google Cloud. It's a one page, there's another one. So you can see there's a lot of them. It's definitely worth to use them, but should we only rely on this? In my opinion, no. It's not enough. Because in security, we should take castle approach, also called defense in depth. Like in medieval castles, with several layers of security, with moats, walls, towers, and other things, we should incorporate security on many layers. So network, load balancers, web application firewalls, so WAFs, servers, applications themselves, code-based verification, browser headers for web applications. How security changes over time, or does it change? Has everyone heard of OWASP? Okay. OWASP is a non-profit organization focusing on improving security of software. It's mostly famous for the OWASP Top 10 report with most critical web application security risks. This report is published around every 4 years. Let's have a look at the recent changelog of that report. This is comparison between 2013 versus 2017. From 2013 report, 8 out of 10 risks have been put into the next report. Only 2 of them have been dropped. If you compare the current report, 2021, versus the previous report, 2017, it's even worse. Every single risk from the top 10 from 2017 have been carried over to the current report from 2021. Only some of them have been merged just to make space for new risks. Think about it for a moment, please. 4 years in IT, it's a lot of time. Back in 2017, we had Java 9. In 2021, Java 17. We changed not only the version of the software we use, but we changed technology. Sometimes we change software development overall. While in application security, we see same bugs, despite we are aware of them and we know them. And despite that many applications and IT contracts base their security also on this report. You may say it's because of legacy applications. In my opinion, it's not only because of the legacy applications. The problem with not signed JOT tokens is known for over 7 years. Yet it still appears on the new applications. This site down below tracks such cases, and the most recent one is from 75 days ago. It's from SharePoint. Let's have a look how we deal with security in development in general. It doesn't matter if you use waterfall or agile. Unfortunately, security often comes as the last part of the process, just before the application is released and deployed. Often, nowadays, development is pretty fast, and security has a problem with catching up with it. But when application is completed, is it ever completed? What about the new features, maintenance, fixes? They come again into the design phase, the coding phase, the testing phase, and just before it's released, it lands on security's guy's desk, who is in trouble because apart from the new feature, he doesn't know what to retest in the application as a whole. That's why there's a concept of shifting security left on the diagram, moving left. So incorporate security to testing, coding, and design phase. This is a great idea because finding security problem earlier means that you can fix them cheaper and quicker. But why there's a paradigm of shifting left? In my opinion, we should say shift everywhere. Incorporate security also in release and deploy phase. From our managers and product owner perspective, the sad fact is the time you spend on security is not the time you spend on the business. Just imagine that you're a lead developer of a project and you and your team have finished ahead of time. And I don't mean 2-3 hours ahead of time. I mean weeks ahead of time. And you go to your boss and say, hey boss, we finished, we completed, we've got 3 weeks left, and we'd like to add some security features and expand threat modeling into the project. And he goes, oh, that's great, because we're thinking of adding new features, and thanks to that, we'll make more money. And what you're saying about security? It's already secure, right? So you see the dilemma. More features, more money, security on the other hand. It would be great if we would be able to tell how secure the application is. Because nowadays we have the problems how to speak to managers about security and how to convince them about security. So if we would have a possibility to classify the security level of application like we do with food, with Nutri-Score, or energy labels with electrical devices, it will be much easier to tell them how secure the application is. And there is such a thing. It's maturity models. And one of them is Software Assurance Maturity Model from OWASP, which evaluates existing software security practices. Please have a look here for a moment. It's divided into 5 groups with 3 subjects in each, and each of them has 2 objectives, and each of those objectives have 3 maturity levels, and each level has 1 question to verify it. That's in total give you 90 questions, and the answer to those questions is one of the 4. No, yes for some, yes for at least half of it, and yes for most or all. Those answers are then mapped into points, which give you your assessment score, which is your maturity level. Looks big, complicated, and scary? Well, I'm not going to say it's easy. It is complex. It requires work of developers, testers, sometimes security guys also, DevOps and more. But in my opinion, it's a great way of talking about security of a project. Let's drill into some of those objectives. training and awareness. For training and awareness, the questions are as follows. Level 1 requires you that you have security awareness trainings which are required, repeatable, consistent, up-to-date, available to everyone, including onboarding. Level 2 requires that those trainings are dedicated to different roles. So they are customized for developers, there is a customized training for testers, customized training for security champion, and so on. Level 3 requires that you have a learning management system to track your trainings and certificates. As you can see, each level gets harder to comply with as it becomes more demanding. Another objective, threat modeling. Who of you is using threat modeling in your projects? At least for critical processes, okay? So there's a couple. Do you know what threat modeling is? Okay, in my opinion, this is really big. And this is really a must-be for at least high-risk applications or critical processes. So let's park software assurance maturity model for a moment and let's talk about threat modeling for a few minutes. What is threat modeling? It's analyzing representation of a system to highlight concerns about security and privacy characteristics. The key thing in threat modeling is answer on the 4 questions. What are we doing? What are we working on? What can go wrong? So we try to anticipate the attack before they occur. We can even try to anticipate the attack before the application is built, if we're doing this during the build up of the application. If this what we are doing, if about the thing what we are doing, what can go wrong in it? And the last question, is this what we're doing when something goes wrong, is it good enough? To analyze software representation, we need a model. So, diagrams. So when you create diagrams of a software, we need to have a look at them closely and look at the process and start to think what could go wrong. If you are a roadrunner running up here and you've got a coyote above you with a heavy anvil, you know it's not safe. It's a common sense. In IT, we of course use our common sense and experience, but not only that. We can also use threat modeling methodologies. And there is 2 I'd like to show you here. Both of them are mnemonics, so it's easier to remember them. First one is DREAD. That stands for potential damage, so how bad the attack could be. Reproducibility, so how easy to reproduce the attack. Exploitability, so tools and knowledge needed to run the attack. Affected users, so how many users can be impacted. And discoverability, so how easy to discover the attack exists. The second method is STRIDE, and that stands for spoofing, so pretending to be someone else, something else. Tampering, data modification. Repudiation, so denying that the action took place. Information disclosure, including data leaks. Denial of service, making system unavailable. And elevation of privileges. And with elevation of privilege, we don't need to think only about the vertical, the standard one, so from user to admin, but also about horizontal. So user A shouldn't be able to run action that is dedicated only for user B. How to use it? So let's take STRIDE because it's more common than DREAD, and think of a scenario of a process in your application. Let's say that you've got an application, when you've got a login page, and you've got a forgotten password functionality. You click on the link, you put your email address, and you get the link and you get the email with a link. Then you can click on it to reset your password. So let's take stride. So we need to check those 6 threads. So spoofing. So I imagine that such a link that you get on your email could look something like this. So your domain, forgotten password, / a number. So you need to think, what is it, this number? Is it a user ID? Then it's very easy to guess. If this number is followed by another number, that's better because it's harder to guess. But if it's auto-incremental number, still for attacker it would be easy to guess. Even without getting the email, he will be able to generate the link and guess how the link looks like. If this number is actually a hash, that's again better because it's harder to guess. But if this hash is a strong hash, cryptographic safe hash, can you brute force it? Is it a short-term valid link? So in my opinion, yes, spoofing, it's possible in this scenario. Tampering, so data modification? Well, not really. You just reset your password, that's all it does. Repudiation, if you have a log and those logs cannot be deleted, that's fine, no repudiation possible. Information disclosure, now that's interesting. If on the forgotten password page you put the email address and the system tells you, okay, we send you the link, you'll be able to reset your password, or no, we don't know this user ID. To me, that's a data disclosure. We tell if a user saw an email, use this system. Even if the system doesn't tell you straight away that yes, we know this email or not, and the message is all the time the same, but when the reset password link is emailed, an action takes about 2-3 seconds, and when the email is unknown, the action takes less than a second, the attacker can still guess if the user exists or not based on the request time. So that's still data disclosure, in my opinion. So yes, it's a data disclosure. Denial of service. Somebody could try to brute force the link. If we don't use strong rate limiting, it's possible that we bring down the service. So yes, it is possible. Elevation of privileges, in my opinion, no, not in this process. That gives us a score of 3 because we got 3 yeses. As you can see, it's not that difficult, and you don't need really security guys to help you with this. You can do it even if you're in your own development team. If you need something more advanced, rather than yes or no answers, you could use something which is called OWASP risk rating. It has 16 factors, so for each of the 6 threads in Stride, you run them against 16 factors. And those factors are grouped into 4 groups. First one is likelihood of threat, and there's 4 factors in each, so there's 4 factors in this one, and you can see the score is from 0 to 9, and you get the hints next to each score, which will help you which option to choose. So there's 4 likelihood of threat, there is 4 likelihood of vulnerability, there is 4 technical impact, and there is last 4 with business impact. Once completed, that gives you overall risk severity, which can be on the matrix down below, critical, high, medium, low, or just information node. So to sum up the threat modeling, first one, you need to identify the processes, especially at least those critical processes. Then you need to rank them by score and decide if this what we're doing is good enough, you accept the risk, or you want to mitigate it. Okay, so let's come back now to the software assurance maturity model. So for threat modeling, the questions are as follows. Level 1 requires that threat modeling is run against the application, especially the high-risk applications, or at least for critical processes, to find architectural design flaws. Level 2 requires that you have a standardized method to run threat modeling, and you review those diagrams, review the threat modeling every time the application have a significant change. And level 3 requires that you review and update the model regularly, so at least annually. Another objective from assurance maturity model: secure architecture, technology management. Questions are as follows. Level 1 requires that you have a list of most important technologies that you use in a project. Level 2 requires that you have a recommended technologies list, and this list is approved by your lead developers and architects. From level 3, it's required that you enforce those technology lists, and you have monitoring. So if some developers try to use technology that is not approved, not reviewed, you get the alert. Another objective: software dependencies. Level 1 requires that you have a knowledge of dependencies that you use in the project. That means that you implement software bill of materials, which is a report with the dependencies that you use in the project. Do you remember log4j vulnerability called log4shell? Do you remember checking repo by repo, project by project? With software bill of materials, you would know it much quicker. Level 2 requires that you have formal process of accepting dependencies that you use in the project. We know that developers are very relaxed in adding dependencies in the projects. If you're using front-end applications and you use npm packages, there is a big chance that you use this package. It's odd. All it does is check if the number is an odd number. It has nearly 2 million per month of downloads. And there's a big chance that you have it in your project not only because one of the developers wanted to use it, but he took dependencies that has dependency, that has dependency, that has dependency, that relies on this. And to me, it's really odd to use such a package. There's another one which is not far off it. It's called isEven. That's pretty much exactly the same. And it's just over 1 million per month downloads. Now imagine that the author of this open source project one day decides that he wants to turn his project into the cryptocurrency mining application. And this means that every application which uses this project and updates the package version will most likely become a cryptocurrency miner too. That's why we need a way of stopping developers being so relaxed in adding dependencies as they like. And that's why this formal process is needed. Level 3 requires that you constantly check for vulnerabilities in dependencies, and if it happens that there is a vulnerability known against dependency, that you fail a build. Also, it requires, which it doesn't say in this question, but it's in the description, that if you use dependencies, open source dependencies, and you use SAST, so scan your statistical analysis against your own code, you should also scan the open source code. Okay, so I'm not going to go through all of those objectives, I only took 4. But once you complete the software assurance maturity model, that gives you maturity score, which is a number. Overall number is one thing, but more important, in my opinion, is the breakdown by every subject, and it can be viewed on a radar chart like this. And this can show you straight away the weaknesses, so areas for improvements. To sum it up, software assurance maturity model can be used for setting security priorities, identifying areas of focus, defining action plans, and it's a great communication framework across the company to talk about security. So let's come back to the start of the presentation and question why security and the perspective of managers and product owners. Yes, that's true. The time you spend on security is not the time you spend on the business features. But we have to provide the business safely. Since ransomware and GDPR, business understand that much better. Let's say that you have completed the software assurance maturity model and your score is 11 out of 45. On itself, 11 out of 45 doesn't sound great, doesn't it? But if you provide this result with the plan of improvements, adding software bill of materials, including threat modeling, trainings and awareness for developers, improving secret management, formalizing the technology management and dependencies, it will move from 11 to 19. And in my opinion, showing measurements of security as a number is a crucial thing when you're talking to business people. Because we well know that business loves numbers and excels. And what they don't like is fines and losing reputations, which will happen if business is not provided safely. I encourage you to explore further software maturity models. There's more. The OWASP one is not the only one. In my opinion, software assurance maturity models are the best answers on to why and how security questions. Thank you for your attention. It's time for your questions. Okay, if there are no questions now, feel free. Yeah.
So you were saying about maturity model. In which moment of development do you see to ask yourself those questions? Is it like from every step of development, or how to assess the application which is already running?
Well, it all depends. So ideally at the start, in the same way as in the ideal world, you wouldn't give developers accessing source code without security trainings, but we know it happens. So if you at the moment you've done this, you first of all you are aware what your weaknesses are. So the earlier you start, the better. If you can do it before you start the project, fantastic. But that's life.
And another question
Yeah.
is you gave us an example of analyzing the user story of forgetting the password.
Yeah.
Do you think it should be a part of like analyzing every user story for such threats, or it also depends?
Well, especially those critical processes. So if there is a process that you can reset your password and somebody can access some user's data, yeah, to me it's critical process, and this process should be analyzed. If it's a process of buying something, the same. But if it's a process of, let's say, adding a comment on a product, to me it's not a critical process. So you need to find those critical processes. And the critical process really is data protection and purchases, because you're talking about money or data protection. Yeah.
How often do you think we should reevaluate this model? Because I assume that if you have a high score, then like wait a year or two, things happen in the project, and then the scores could be it can change. So how often we should do it?
So software maturity model itself tells that this model should be the threat modeling, let's say, should be annually reviewed, and this is the highest level. So again, it depends. If you know that there is some significant change in technology, you should review the model. If the application stays as is, and if you know that, let's say there's some vulnerability or something changes around technologies, let's say in the browsers, then this is the time probably to review the model. Any more questions? I will be around here, so feel free to talk to me. If you like the talk, please scan the QR code and vote. If you didn't like the talk, please don't vote. Enjoy the conference. Thank you.